Hey, welcome back to the second section of our journey through the Lonely-Lobster application. In the last section, we saw how to load a configuration file into the browser and have a view on it via the editor. Now it's time to send this configuration to the backend, let the backend instantiate a system, and run the simulations. In order to do so, as I mentioned before, you have to log on to the backend, and that's done via this symbol over here. And as I have been lately logged on, my access token is still valid, and I'm being logged on instantaneously. So it's Gerold here, which is fine. And also it shows the event logged in successfully. Once you have a guest account, it will be the same for you. Now, this run button over here is now black and no longer grayed out. So it's active. And now let's click on it. And what now shows up is the system built up from the configuration that we have seen in the editor. I will walk you through now the elements that you see here. It seems to be rather confusing at the moment, but you will see it's not that complicated actually. What you see here is the time. So the time is 0. We have not yet started the simulation. And time proceeds in steps of 1. So it's a discrete proceeding of time, and it starts with 0 and it goes on. And then you have a number of iterations you would like to do. So you can enter here, for instance, 20. And once you hit the run button, it proceeds from time 0 to time 20. And then what else have we got here? We have the value chain alpha that we have seen in the editor. And there are 2 process steps, 1 and 2, with their associated norm efforts, 1 and 2 respectively here. And you see the value that is generated by this alpha value chain. And then you have the 2 process steps, one of which again is this, and the white areas here are the inventories. We will see how they are being used a little later. And then you have the workers assigned to these process steps. You have here Sally assigned to process step 1 and also Rusty and Sally assigned to process step 2. Then you find these controls over here called throughput and injection probability. Throughput is basically the number of new work orders being injected into the first process step, here 1, at every time unit. When the simulation proceeds from one time step to the next one, then always one new work order will be injected in this configuration into the value chain. And the second parameter is a little bit more tricky. If it's 1, then it's just saying it's maximal smooth. So whenever a new item is ready to be injected, it will be injected right away. If you lower that value here, the inflow gets a little more rougher and less predictable. But overall, the throughput will be still 1. So you can play around with that, and you can find more details in the documentation. Okay, that was it. I think we are ready to go, and I push now the run button and see what happens if we proceed to time 20 and injecting one new work item at every time unit. So off we go. And what do we see now here? These boxes here are the work items, the things we got to work on. And we call them work orders once they are injected newly into the process step. When they're being worked in the value chain, then we say it's a work item. And then once the work item is then finally done by the value chain, then it is ending up here in the output basket, which is the place where all the end products are being collected and from which we can then derive overall system statistics. Okay, now 20 new work items or work orders have been injected into the value chain, and then you see here the distribution of these work items. What does this mean? The x-axis shows you the elapsed time of a work item in a process step. So you see 19, for instance, if you hover over it, you see that the accumulated effort has been 0. No one has worked on it yet. So Sally has not found time to work 19. And the elapsed time is 1. And if you go on to 17, you will see the elapsed time is 3. So this one has been waiting for 3 time units already without being worked. But 6 is even worse. 6 has been waiting for 14 time units, 14 minutes, or whatever you want to call, whatever your unit is, and has not yet been worked by Sally. However, Sally worked on 18. That means 18 flowed from process step 1 to process step 2. You see there was 1 unit in the time unit 20, 1 unit, 1 work item flowed over. It might have been 18. And 18 is now in the second process step, and the elapsed time is 1 there, and the accumulated effort is 0. No one has worked yet on it, neither Rusty nor Sally. But you see here 14. 14 has an accumulated effort of 1, and the darker it gets, the more work has been done on this work item, and the elapsed time is 6. And once the accumulated effort is 2, then it finally flows into the output basket where you find all the end results that are then go to the customer. Now here we have also an x-axis which basically shows this overall cycle time of the value chain. So we have 3 items, 0, 4, and 15 here that have a cycle time of 3. So the elapsed time basically through the entire value chain was 3. And I think that makes a lot of sense. That's the minimal cycle time, as we have to work 1 unit of work here and 2 units of work here. So we have a norm effort of combined 3, and that's the minimal cycle time. And keep in mind, just at every time unit, just 1 worker can work a work item, so that the minimal cycle time ends up to be 3. But we have also delays here. We have cycle time 4 and even here 12. That was because this work item 8 was queuing up somewhere in one of these 2 process steps or in both of them. So that's how to interpret the simulation results, and you can just push the run button again and it goes on and on. You can also start it and stop it right in the middle somewhere and then resume. But if you want to start all over again, you can reset it, and then you can tweak around maybe the input parameters, and you can just do another run. And I show you what happens if you run it with 100, and then you see how the inflow comes in a little bit rough. It totally overloads Sally. She's not capable of coping with the incoming work. And as no big surprise, the work that is being finished is spread all over the place. We have here customers that had to wait for elapsed time of 54. That is a guarantee to have unhappy customers. Also, you find here a couple of statistics, and that I will show you in the next video. So bear with me. See you in a minute.